Our universe is infinitely large. In it you can find many scary, dark, bewitching places where a human could never survive. Every day, scientists discover such places, galaxies, stars, planets that amaze us with their unique and unusual properties. In this video, I propose to visit the most amazing exoplanets in our observable universe. There are a huge number of exoplanets in the universe. Each of them has its own characteristics. Some planets are similar to Earth, while others on the contrary are real personification of hell. Any planet is an extremely faint light source compared to its parent star, and the light coming from exoplanets is very difficult to recognize due to the high brightness of the parent star. Somehow we find them. Let's find out. Indeed, there are several methods that help us detect planets in other systems. In general, it is very difficult to detect and resolve them directly from their host star. Planets orbiting far enough from stars to be resolved reflect very little starlight, so planets are detected through their thermal emission instead. It is easier to obtain images when the star system is relatively near to the Sun, and when the planet is especially large, considerably larger than Jupiter. This method consists of precisely measuring a star's position in the sky and observing how that position changes over time. If a planet orbits a star, then its gravitational effect on the star will cause the star itself to move in a small orbit. The star and planet will orbit around their common center of mass. While the above method provides information about a planet's mass, this photometric method can determine the radius of a planet. If a planet crosses in front of its parent star's disk, then the observed visual brightness of the star drops a small amount. The amount the star dims depends on the relative sizes of the star and the planet. And the first planet is the gas giant TRS-2b, located 750 light-years away from the Solar System. The planet has been identified in 2011 as the darkest known exoplanet. Each planet reflects a certain percentage of light that hits it. TRS-2b reflecting less than 1% of any light that hits it. Therefore, it does not even look like a planet, but a black hole. TRS-2b is located very close to its star, and belongs to the class of planets known as hot Jupiters. The planet is likely to be tidally locked to the parent star. The planetary night-side temperature was estimated to be equal to 1800 degrees Kelvin. Korot-7b is an exoplanet orbiting the star Korot-7 in the constellation of Monoceros, 489 light-years from Earth. It was first detected photometrically by the French-led Korot mission. Until the announcement of Kepler-10b in January 2011, it was the smallest exoplanet to have its diameter measured, at 1.5 times that of the Earth. And the first potential extrasolar terrestrial planet to be found. The exoplanet has a very short orbital period, revolving around its host star in about 20 hours. The mass of this planet is about 6 masses of the Earth. Korot-7b is always turned one side toward host star, making one side of it a lava ocean with a temperature of 2900 degrees Kelvin. And the other side frozen water ice with a temperature of about 320 degrees Kelvin. Computer models have shown that Korot-7b may be the rocky remnant of a Saturn-sized gas giant that has been evaporated by the star to its core. Algol-TR-56b is a hot Jupiter-class exoplanet orbiting a yellow dwarf. The distance to the system in which this planet is located is about 4,900 light-years away, and its mass is about 1.5 masses of Jupiter. Scientists believe that the surface temperature of this planet can reach 2000 degrees Kelvin. The peculiarity of this planet is its precipitation. The rains on this planet consist of drops of iron. Scientists believe that the atmosphere of this planet consists of clouds in which iron atoms are concentrated. High temperatures and iron clouds produce rains of liquid iron. PSRB 1257 plus 12c is a super-Earth exoplanet orbiting the pulsar PSRB 1257 plus 12 approximately 2,315 light-years away from Earth in the constellation of Virgo. It was one of the first planets ever discovered outside the solar system. This exoplanet has a radius and mass larger than that of Earth. It has an equilibrium temperature of 567 degrees Kelvin, a mass of 3.9 mass of the Earth and a likely 1.5 radius of the Earth. The planet orbits a pulsar. The stellar remnant has a mass of 1.4 mass of the Sun and a radius of around 6 miles. PSRB 1257 plus 12c orbits its host star about every 98 days at a distance of 0.46 astronomical units. This system is the remnant of what used to be a normal system similar to ours. Its end came when the star exploded. The explosion was accompanied by the ejection of a huge amount of matter from the outer shell of the star, which destroyed everything on these planets. All that was left of the planets themselves were rocky shells. Kepler 70b is a rocky exoplanet, with a mass of half the Earth. This exoplanet orbits its host star about every 5 hours and it's extremely close to its star. The peculiarity of this planet is that it is hotter than the Sun. While the surface temperature of the Sun is 5,780 degrees Kelvin, the surface temperature of this planet is 7,600 degrees Kelvin. At the moment, it is the hottest exoplanet discovered. Our Earth is a very beautiful planet to the human eye. The blue color of the sky that we see on the surface of the Earth. The oceans, which form a blue color from space. And this color we associate with something safe. The next planet is something visually similar to our planet. But let's take a closer look at it. HD 189,733b is a bright blue gas giant, comparable in size to Jupiter, orbiting an orange dwarf and 30 times closer to it than Earth is to the Sun. The surface temperature of this planet is 1,200 degrees Kelvin on the light side and 700 degrees Kelvin on the dark side. This planet was discovered in 2005. It orbits its parent star every 2.2 days. As the closest transiting hot Jupiter to Earth, HD 189,733b is the subject of extensive atmospheric studies. This beautiful and pleasant blue color is formed by the atmosphere of the gas giant, which consists of iron, aluminum oxide and silicates. The winds on this planet have a speed of about 2,500 meters per second. The high temperature turns the silicates into shards of glass. As a consequence, the planet has constant rains of glass, which spread at a tremendous speed. Our latest planet today is the exoplanet Teegarden b. It is 12 light-years away from our solar system and was discovered in 2019. The uniqueness of this planet is that its viability index is estimated at 95%. The mass of this planet is almost equal to that of Earth. According to modeling, the probability that conditions on Teegarden b are the same as on Earth is 60%. This means that it has liquid water, moderate temperatures and weather conditions. If so, the planet has a high chance of producing complex organic life. The approximate average temperature on it, scientists estimate, is 301 degrees Kelvin. Teegarden's star is a dim red dwarf, but the planet Teegarden b is closer to its star than Mercury is to the Sun. The planet makes a complete revolution around the star in less than 5 days. The planet faces one side of its star. It has a powerful tidal coupling to which known terrestrial life could hardly adapt. Because of this, the planet's climate can have extremely dispersed temperatures, which in turn prevents the emergence of complex life forms. The planet's star is a red dwarf. Stars of this type regularly have powerful outbursts, which, given the proximity of the planet, would destroy the atmosphere of Teegarden b. If this is true, then the planet has no protection even for the simplest organisms from the destructive effects of the rays. But we should not forget that the most unique planet for us remains our Earth. And such amazing exoplanets, so far, remain for us only objects for research.